Hot gas reheat is one of the most important humidity control strategies used in commercial HVAC systems, especially in buildings where excessive moisture becomes a major concern. In many facilities, the challenge is not simply cooling the space, but removing humidity without making occupants uncomfortable. This is commonly seen in indoor pools, gymnasiums, aerobic studios, locker rooms, schools, supermarkets, and other high-occupancy buildings where large amounts of moisture are constantly being introduced into the air. Most people think air conditioning systems only lower temperature, but HVAC systems actually perform two separate functions. One is sensible cooling, which reduces the air temperature, and the other is latent cooling, which removes moisture from the air. In certain buildings, the latent load becomes the dominant concern. Indoor pools continuously generate moisture through evaporation, while gyms and aerobic areas produce humidity from perspiration and heavy breathing. In many cases, outdoor ventilation air also introduces additional moisture into the building. To remove humidity effectively, the evaporator coil inside the packaged unit must become very cold. As warm, humid air passes across the cooling coil, moisture condenses on the coil surface and drains away. The colder the coil becomes, the more moisture the system can remove from the air. However, this creates a new problem. The supply air leaving the unit may now be far colder than the space actually requires. The building may still need additional dehumidification, but it no longer needs more sensible cooling. This is where hot gas reheat becomes extremely valuable. The system intentionally overcools the air to remove additional moisture, then reheats the air before it is delivered back into the occupied space. In other words, the HVAC system separates moisture removal from temperature control. The process works by redirecting a portion of the hot refrigerant gas, leaving the compressor through a reheat coil located downstream of the evaporator coil. Instead of sending all of the hot refrigerant directly to the condenser, some of that heat is reused to warm the cold supply air after dehumidification has already occurred. For example, the evaporator coil may cool the air down to approximately 50 degrees in order to maximize moisture removal, but the reheat coil may then raise the supply air temperature back up to around 65 degrees before delivering it to the space. The result is dry, comfortable air without excessive overcooling. One of the biggest misconceptions in HVAC is the idea that colder air automatically creates better comfort. In reality, humidity plays a massive role in how occupants feel inside a building. A space can feel cold and humid at the same time, creating a clammy and uncomfortable environment. Standard thermostats only monitor temperature and do not directly control moisture levels, so without proper humidity control, buildings may suffer from condensation, mold growth, odors, corrosion, and poor indoor air quality. This becomes especially important in facilities such as natatoriums and indoor swimming pools, where evaporation creates extremely high latent loads. Without aggressive dehumidification, windows fog up, metal components begin to corrode, and building materials slowly deteriorate over time. Gyms and aerobic studios face similar issues because of the large amount of moisture generated by active occupants. Schools, auditoriums, healthcare facilities, and supermarkets also commonly use hot gas reheat systems to stabilize indoor humidity and maintain occupant comfort. Some HVAC systems accomplish reheating using electric resistance heat, but this method consumes a large amount of electrical energy because the system is essentially cooling the air and then reheating it using electric heaters. Hot gas reheat is often considered a more efficient solution because it reuses heat that already exists within the refrigeration cycle. Instead of rejecting all compressor heat outdoors, part of that heat is recycled and used for reheating the supply air. While hot gas reheat still increases compressor runtime and is not considered free cooling, it is typically far more energy efficient than electric reheat systems. Modern packaged rooftop units often include advanced humidity control strategies that use humidity sensors, dew point sensors, supply air temperature sensors, and dedicated dehumidification controls. When humidity levels rise above the desired set point, the cooling system can continue operating specifically for latent heat removal, while the hot gas reheat coil maintains a comfortable supply air temperature. Some systems also incorporate variable speed fans, modulating compressors, dedicated outdoor air systems, and energy recovery components to further improve humidity control and overall efficiency. Ultimately, hot gas reheat allows HVAC systems to prioritize moisture removal without sacrificing occupant comfort. In many commercial applications, the building does not necessarily need colder air. What it truly needs is drier air. That is why hot gas reheat has become such an important strategy in modern HVAC design, particularly in buildings where humidity control is critical for comfort, indoor air quality, and long-term building protection. If you found this video helpful, be sure to check out our HVAC and plumbing estimating spreadsheets to streamline your construction bidding process. Check out our HVAC, electrical, and plumbing construction forms to help you run your business, and explore our online courses for in-depth training.